months, and then
Okay, well, we're gonna go ahead and get started because it's 4 o'clock and I want to be very respectful of your time because I know you guys are all super busy, but it's fantastic to see you guys here. Thanks for being here for our informational webinar. My goal today is really to, always to meet you all and to hear where you guys are up to and how your semesters are going, but really to give you the broad overview of what the KidWind Challenge is, the main rules, which have not changed very much at all since last year, and then to really get into the logistics of what this year is going to look like, and answer any questions that you guys have. And I'm assuming it won't take the full hour, but if it does, I'm happy to stay and continue the conversation. So with that, I'm going to go ahead and share my screen. And we can go ahead and my mouse wants to be happy. There we are. Okay. Did everybody see my screen? Sweet. Yeah. We're going to say that's a yes. Awesome. Okay. So for those of you who don't know me, I'm Remy Pangle. I work here at the Center for the Advancement of Sustainable Energy at JMU. We are the coordinators of the Virginia KidWind Renewable Energy Challenges. So we do have wind and solar competitions. We're going to go through a lot of stuff. Like I said, it's all recorded and I'm happy to share the slides later as well. The website here on the front page, that is our Renewable Energy Challenge page that has all of the Virginia specifics. I'm working constantly and currently to get all of the information up there. We still do not have all the dates for everything yet. So this is a great site. You're going to want to check back regularly. You can also go there to join the mailing list. And I wouldn't just join like the case mailing list, but if you go into the coach resources, you can like join the newsletter, I guess is maybe what it's called. And that way you're on a list to make sure you're getting the updates of all of this stuff. So anyway, so with that, again, I would love to just do a quick like around the Zoom room. And the way that I like to run this is I'm going to call on the first person I see, and then you can give a quick, who you are, what you teach. Have you ever done this before? Why are you excited? And then you get to pick the next person on the list. And hopefully that way we'll get through everybody. So Zach, you're the first person on my list. So I'm going to let you introduce yourself first.
I am Zach DeMoss. I work at North Cross School in Roanoke. I'm the IT guy by day. And on weekends and nights and early mornings, I'm the robotics guy. And so last year we had a middle school solar team. And this year we have another middle school solar team and 2 lower school wind teams. And so that's what we're doing this year. But we're excited.
Awesome.
And Aaron's up after me.
Hi, I'm Erin. I have not done the KidWind Challenge before, but I'm working together with Caitlin Grant at Elkton Middle School in Rockingham County. And we have a STEM program this year that we're starting. So we're going to have our students do the solar challenge. And Christina is the next on my list. Hi, I'm Christina.
So Christina and Jamie are sitting next to each other.
Can one of them please mute themselves?
We both teach 5th grade together. And we saw a KidWind presentation at a maker conference we went to last year. So we're just kind of curious to see what it would look like in our school setting. So.
And where do you teach?
I'll pick Blair.
What is that?
Was that my turn?
Sure.
Sure. Hi, I'm Blair. I don't teach anything. I got involved with KidWind from Diane Painter. I met her at Makersmiths here in Purcellville, trying to get my 4th grader involved in the wind project. So we're trying to get a team together from Banneker Elementary here in Middleburg.
Awesome.
And I see Oliver is next on my list. So Oliver, you're up.
Hi. Yeah, I'm also not a teacher. I'm a volunteer coach. I'm also with the Makersmiths, as Diane is, and Jim Waldron. I think I saw you. If that's the same Jim Waldron. I was kind of just helping out a little bit with a solar team 2 years ago, and last year coached my daughter and one of her schoolmates as a middle school wind team, and we made it all the way to Worlds, where we learned that our power output was limited not by our design but by the generator. So this year we're going for the open category, and it'll be a high school team because my daughter's in ninth grade. So we'll see whether we can recruit either through Makersmiths or through her school or some other way, but we will need more people on our team. But it's going to be exciting this year. And the next one, yeah, I think Jamie, I know you're on the same mic or in the same room as Christina, but I think it's your turn.
Okay, well, I'm still Jamie. At Heartwoods.
Sorry.
We are down in Fredericksburg, Virginia. Like I said, Christina and I. So.
Oh, you're like the same basically. I'm sorry.
Otherwise,
Gotcha.
Jana, have you gone?
No, I haven't. So I'm a teacher at Lincoln Elementary in Loudoun County. And I also have gotten or contacted by Diane Painter in Percival to have a KidWind team. And I'm going to join with the 4th grade teacher who's also on this call. Her name is Jennifer Reed. And we're going to work together with her, and Diane Painter is going to be helping us. And we're really excited to try something new.
Awesome. Jennifer, do you want to go next then?
Sure. Can you hear me?
We can.
Okay. Hi. So I'm Jennifer Reed. I'm the 4th grade teacher at Lincoln, and I'll be working with Jana Bigney. This will be my first time involved in something like this, so I'm really excited. And we also have, I'll tag Amy Cornell because she is our gifted teacher who's going to be joining us as well.
Yeah, I'm right here. I'm the gifted resource teacher at Lincoln, and I'm excited to be coordinating with both Janet and Jen for Lincoln Elementary.
Awesome. And I guess is Molly, are you the last one, or did we forget somebody else?
I'm here. Can you hear me?
Again.
Yep. Okay. So I am Molly Kling. I'm the enrichment specialist, so kind of like a private school equivalent of gifted teacher for Walsingham Academy in Williamsburg. And we piloted the program last year with our 5th graders, and they really loved it, had a great time. I got into the program through Kim Ward, who worked at Walsingham before coming last year to pitch in on the KidWind team. And so I'm looking forward to another year with a group of new 5th graders in the wind division.
Awesome. And then did we miss anybody? Jim, did we get you? Okay. Well, without anybody speaking up, it's really nice to meet you all. Thank you for giving me kind of the lay of the land here, of, who's been through the ringer and who's new to this. Again, I'm with the Center for the Advancement of Sustainable Energy. We are at JMU, and we work throughout Virginia, doing a lot of different things in the research and development space and the outreach space, but I focus my attention here on the education and training space. And of course, our flagship activity is the KidWind Challenge. And so these are wind and solar competitions. They're hands-on design challenges that engage students through the lens of wind or solar energy. The teams design, construct, and test small-scale wind turbines or solar houses this year again. And these events happen not just here in Virginia, but all over the US and all over the world. So it is a really fun and exciting program. And many of the folks here on the call who have done this before, feel free to chime in and say how much you love it. But I think it's just such a great way to really end the semester and the year with a great project for students to apply their knowledge and really feel like they're doing something real and something relevant. For those of you who are new to the competition, we do have a YouTube channel. And so this picture in the upper right-hand corner of me looking weird during COVID is me explaining what the wind and solar challenges are in a little bit more detail. And that's one of the videos on our YouTube channel. So if you don't feel comfortable trying to figure out how you're going to present this to your kids, a lot of folks just use that video. So feel free to do the same. I can go through a little bit more of what's on that YouTube channel because there's a lot of resources on there. And again, any of the folks that have done this before, if you have a resource on that channel that you liked, you know, it'd be great to, you know, share that feedback with the others on the call. But I'm really going to dig into the KidWind Challenge and its structure and its rules next. And then I can stop, take some questions, and then we can go into kind of what Virginia's competition season is going to look like this year. So KidWind is an organization, is a nonprofit based in Minnesota, and they host these all over the world. They really do a lot in the teacher training space. They develop curriculum. They have like gear, stuff for the classroom. And then all of that is really kind of leading kids to this KidWind Challenge, this competition. There are in-person competitions. There's an online challenge. There's a simulation challenge, which is using the White Box learning platform. And then winners from all of those then get invited to come to KidWind Worlds, which I hate to say it, I don't know if it's going to happen this year. It is a very tough funding environment right now. I'm sure I don't need to tell you all, but it is rough out there, and it's a very expensive event for KidWind. So we will know by the end of the calendar year if they've raised the dollars to support a KidWind Worlds. So just wanted to throw that out there. We can all hope, but we will definitely have a state level competition here in Virginia, and that's super fun for folks to compete at a regional and then be able to move on to states, even if there isn't a Worlds. Again, we host in-person competitions here in Virginia, and we'll get into that a little bit later. The online competition is another great way to kind of dip your toe into the competition. It's not as rigorous. There's not as many requirements, but it still gives the kids an opportunity to apply what they're learning and build cool stuff. And those are taken on a rolling deadline. And then the projects are evaluated every quarter. So as long as you get your project in by the end of October, it'll be evaluated in the first quarter against all the other teams that have submitted. And just a note of strategy, nobody submits in the first quarter. So if you really want to, you know, get recognized and your kids, you know, that is a good quarter to submit in because there's not a lot of competition. As you get closer and closer to that April 1st, quarter 3, you see a lot more because of the cycle of how we teach and prepare coaches for the competition. Any questions right there about, I can go into more about these online competitions and show you the platform and things like that if people are interested. Awesome. Moving on. Oh, I guess we're going to talk about Virginia first. Okay. I forgot how I put my slides together. So here in Virginia, we are planning 4 in-person regional competitions that'll lead to a state competition at JMU in April 11th, which is the second Saturday of the month. It is not Easter. I checked this year. That's what we're planning for. And I know last year we did 6 regional competitions, but it is a tough funding environment. So I hope you all understand that we had to kind of decide how to spend the small amount of dollars that we have. So we are hosting one. We're aiming for March 3rd at Nauticus in Norfolk. I think we might have put out that it was going to be March 4th, but I realized that I have a competition on March 5th in Pennsylvania that I have to be at. So I'm asking them to move it to the 3rd. So just, you know, if you're in that Virginia Beach region, Molly, I'm looking at you mainly, just bear with me. I promise I'll confirm that as soon as I know for sure. In the Southwest region, we are going to be hosting it at the Higher Education Center in Abingdon, Virginia on March 10th. We will be hosting a regional in Charlottesville. I don't know what the location is quite yet. We're trying to get it at the UVA Technology Park. So it's off campus, but still affiliated with UVA. I don't have a confirmation that they would like to host it, and I obviously don't have a date. In Northern Virginia, we are going to be hosting it this year at the Potomac Science Center. It's affiliated with George Mason, which is over in Woodbridge. Still working on a date with them, but again, we're aiming for March, if you haven't caught the trend, and not a Monday and not a Friday, because we understand the challenges of both of those. So it'll be a Tuesday, Wednesday, or Thursday. And at this point, it'll be either the third or fourth week in March, because that's what's left here. So again, I apologize for not having all this locked down, but it has been tough. It was late even getting the funds to know that we could do this. So I appreciate you bearing with me. We plan to have these, by the end of October locked in, because, well, we need to get things moving. But we do have teacher trainings scheduled, and we'll get to that in a little bit. When it comes time to register for a KidWind event, we will be doing the registrations through the KidWind website. And if you go to the website and you look at the in-person events, eventually all of our Virginia things will pop up on that map, and including all of our teacher workshops. So you can always go there, and registration is free, at least for the time being. We're going to hope to keep it free as long as we can. But with funds tightening up, we never know what the new structure will be. When it comes to the competition, we do have grade level divisions, within each of the competitions. So within the wind competition and the solar competition, we break it down into high school, which is 9th through 12th. And we break it down, and it says middle school 4th through 8th. But if we have enough 4th and 5th grade teams register at any given event, we will create an elementary school division. But if we only get 5 teams that register and they range from 4th through 8th, rather than having 2 competitions where you are not competing against but like 1 or 2 people, we push them together to make a larger division. So I can always explain that later if there are questions. Within the wind competition, and you might have heard some reference to this, there are different divisions based on your generator. So within a grade level division, you'll also have generator divisions. It gets a little confusing, but I promise it makes sense when you get there. So most teams compete with the KidWind generator that comes in your kit. That is the KidWind generator division. That's what most people are in. But if you're like some folks and you're limited by that little generator and you're just, advancing so fast and you really want to do more, the open division allows you to purchase a commercial AC or DC generator, any generator you want, and use that instead. But there is also, oh, sorry, go ahead.
Quick question while we're talking that might be one of those nitpicking questions, but you're saying commercially sold. Can we use like DC motors that we get from discarded things? Okay.
Yeah, exactly. Sorry. A pre-assembled generator that you get from somewhere else. Yeah, it says commercially sold here, but yes, that's exactly what we're talking about. So if you pull the alternator out of your printer and use that instead, that is open division. It only becomes home built division if you actually are spinning the coils and building the generator from scratch. But if you're using anything pre-wound or pre-assembled in terms of a generator, that is going to be like the advanced or open division.
Okay,
Does
thanks.
that,
One-
okay.
One more quick question on that. For the KidWind generator, there are two kits online. One is a mini kit, one is a advanced kit. Is it the same grouping?
Yeah, so that's a good point. When you get and you're talking about from Vernier, is that correct?
Mhm.
So when you get the kit from Vernier, that is a good point that we need to make. You get two different generators. And I think it's in both, and it might only be in the advanced one, but you get the DC generator. We call it the fat one because it's like a wider diameter, but it's a little bit shorter in depth. And that is the KidWind generator. And then the kit also comes with another generator that is skinnier and it's longer in depth, and that is a high torque generator. So if you show up with the high torque generator, you get put in the open division because the KidWind generator is just the fat one that we call. And I should be good and have them both sitting here with me, but I don't have them here. But if you have any questions on if you're using a KidWind generator or a high torque generator that comes in your kit, you can always Zoom me or call me and we can FaceTime and I can help you. Thank you, Zach. That's very helpful. Okay, so I'm gonna get into the rules here because this is the part that's we got to understand. But the one thing that I want to kind of preface with is the whole goal of KidWind was to avoid the 400-page rule book like robotics and, Lego League and all those kind of things have, and to keep it simple. So you'll find that the rules are relatively simple. But the other thing that's great about these competitions, if you haven't done this before, is I like the way that it's very well rounded. So this is a bit of a breakdown. This varies from challenge to challenge, but we try to stick to that pretty good here in Virginia. About 35% of the score, or 35 of your 100 points at the competition, come from how much energy you produce in the wind tunnel. This is for the wind competition. Then you go into a judging room, and the students have to present to a panel of judges, and in that, they are getting judged on their turbine design. So they kind of go through each part and explain how they chose this design for their blades, or why their tower looks like this, or why they have a gearbox. And then they are judged on their written documentation of that design. So it's not just, awesome, I made these decisions, but like, here's the data that backs it up. We did 50 experiments with 50 different blade sets, and this is the one that worked. Engineering notebooks, graphs and charts on their poster board, whatever it is, they need to be able to show that they collected data and they use that to drive their design decisions. And that whole thing is 50 points. So 35 points is how fun it is in that wind tunnel. 50 points is the really annoying part of having to present to the judges, but it's super important. And then the last 15 points, at regionals, we tend to offer a 15-point knowledge quiz. At states, they will get a 15-point instant challenge. And the reason that we do two different things is that when they go to Worlds, if there is a Worlds, they have to do both a knowledge quiz and instant challenges. So this allows us to kind of prepare them for what they're going to see at Worlds. Any questions about the point distribution? All the components of a KidWind competition? Okay. So for the wind competition, like I said, the rules are pretty, I guess, pretty logical. Like, it has to fit in the wind tunnel. And our wind tunnel is 48 by 48 inch cube. Now, for those of you who want to maximize your blade rotor diameter, I wouldn't aim for 48 inch blade diameter. Or rotor diameter, because the wind tunnel has got a plastic sheath on it, and when the air gets pulled through, it sucks in. So I would aim for, like 23-inch blades or 22-inch blades. Because we get a lot of kids who complain that I have 24-inch blades and I'm whacking the side. So just think about that. There is some error and some give to the tunnel, and then you also have to consider the hub, things like that. So, maximize, but but aim for like 46 or 47 inches. The power that is produced by the wind turbine has to come from the wind in the wind tunnel. So you can't have like a capacitor or batteries or something else. The turbine has to start by itself. That's actually a really big one because when you get high gear ratios and crazy airfoils, I have sat there for 30 seconds waiting for the turbine to spin, but they cannot go in there and nudge it with their finger. It's either going to spin or it's not going to spin. But you definitely can't go in there and nudge it. The turbines can be either vertical or horizontal. So, definitely encourage creativity there. We do allow gears, and prepackaged gearboxes are allowed, but you can imagine from a judging standpoint, if they're looking for your understanding of how a gearbox is put together, you may want to not use a prepackaged one that you can see the pieces and they can really understand how they did that. Blades must be made by the team. That sounds a little silly, but there are some kits that are sold by Vernier, which is the X on the bottom, that come with these pre-made airfoil balsa sheets. And if you don't know that you've got them, they look like every other balsa sheet until you look at them from the side and they have this slight airfoil shape. So you got to be careful that you don't use those. I've also seen kids like pull airplane blades off of like a model airplane and stick them on dowels and use those as wind turbines, and fan blades, things like that. So definitely no pre-made blade sets. We really want the kids to be creative. Yeah, they can only, turbines can only use one KidWind generator. Although last year, I feel like they allowed if you wanted to use 2 generators together, you would be in the open division. So we did have a couple of teams try that last year, maybe with like some planetary gearboxes and things like that. But that's not usually a thing. But that you can kind of disregard that rule because now they've allowed that to increase creativity. But the next rule, every team must have their own tower. So especially for teams just starting out, especially in the classroom, you build one wind turbine and then you just have the kids pop the hub and the blades off so that they can kind of test different blade designs. And that's great in the classroom. But when you come to competition, they need to have a whole turbine. And that's not because we're being mean or wanting you to spend more money. The key is that if you were to have one team want to be in the wind tunnel when the other team needs to go to judging, they can't share a tower that way because they have to bring the whole turbine with them. So it really is just so that they have the flexibility of making sure they're in multiple different spaces at the same time. And then turbines just need to be safe. Again, we used to say no metal blades, but then we had this lovely turbine with metal blades, but they were like welded and soldered and there was no way those things were flying off. So the judges deemed it was safe and we let it go. So we had to alter that rule a little. So as long as it's safe, like please don't take knives and attach them with duct tape, then we're good, the things that kids will come up with. And that's really it in terms of the rules. And then what happens at the competition is they go into the wind tunnel and we test their turbine in our wind tunnel. Which our wind tunnels vary, but 3.5 meters per second is pretty normal. Some of the ones that you'll see at Worlds, if you end up at Worlds, will be closer to 6 to 8 meters per second, really. But ours run more in that kind of 3 to 4 meters per second. The students test in the wind tunnel, and if they want an official test, we use the Vernier Go Direct energy sensor, and it's a 30-second test. So we hook it up and we let it run for 30 seconds, and over 30 seconds it gives us a joules output, and that is what they're judged on. And so for the joules, they're measuring the voltage, but also the current, and there's a 30 ohm resistor on the circuit. And that's the way the energy sensor works. And it says must be an old slide because it's not over 60 seconds. It's a 30-second test. So if people have questions about how we do that or how to do that with a multimeter, we have videos on that on our YouTube channel. And I can show you where to purchase the energy sensor on the Vernier site.
Does that test include spin up time?
No, so so the protocol in the wind tunnel is the kids, so no adults in the wind tunnel. The kids go in, they hook up their positive and negative leads to the monitor. Then they get out and they tell the tunnel operator that they want to start the wind tunnel. And then at that point, they can stare at it for a couple of, until they think it's spun up. And that's for them, an educational piece. And then once they think it's at top speed, then they say, can you please collect data for me? Hopefully that politely, we can only hope. And then, like I said, there's a whole judging
quick question.
piece. Oh, of course,
Sorry.
Oliver.
The resistor, I feel like in the past, because of the high energy that's possibly being produced in the open category, you can bring your own loads.
Yeah,
right? And then
you are correct. In the open and the home built divisions, you are to provide your own load to match your generator.
okay, thanks.
Yes. Yeah, that's a very good point. Thank you. You're welcome to use the 30 ohm resistor in the energy sensor, but a lot of teams will optimize and use a different load. The judging piece is very comprehensive. The judging sheets are on our website, so it's not a secret what we're going to judge the students on and how many points they get, and what we're expecting them to demonstrate in each of these. But we literally have like them kind of go through their turbine. So we judge them on their blade designs, we judge them on the drive chain, how much innovation they brought to the project, if they were independent, their materials selection, their documentation, their delivery, and depth of their presentation. So as you can see from the small picture on the side, is that a lot of the points really come more from the presentation and the documentation itself. And it's only like, what is it? 18 points are on the design itself. And we'll go into a little bit more about documentation and what that looks like. The wind teams are required to fill out this wind profile form. Again, this is a little bit cart before the horse here, but the idea is this is something that you can hand to the judges, and they keep this along with, sometimes they'll take a picture of you so that they can remember who you are after they judge 20 teams. They know, oh, this was the team that had 5 blades and they looked like saber-tooth tiger, or I don't know, whatever they looked like. So this is just a helpful way for them to come back to remember who the teams are. So this is an important piece of information that you fill out at the very end, like right before you come.
Hey, Remy.
Yes, ma'am.
With the change to 4 sites from 6 last year, are we allowed to bring more than 3 teams?
I don't think so. I think that it's gonna just be, I'm gonna have to really do a bit of a job to keep the numbers down. And I feel bad because I know that the Virginia Beach Challenge, like last year, we let in like 40 teams. But I just, from a reality standpoint, it's me. And I don't have any staff anymore because of all of our funding challenges. So I have to be a little bit mean this year, because otherwise I'm going to go insane trying to do everything. So unfortunately, I don't think so. But we can talk about strategies for how we can help you get all the kids involved, but give them maybe another opportunity to participate in a different way.
Okay, thanks.
Yeah, because I hate to say no to kids. We want them to be involved, but I also only have so many time in the day, so we'll have to balance that. The no shrouds rule still stands. Again, we don't usually see these at regionals and at states. We saw them mostly at Worlds, but yeah, it's not a thing anymore. So I guess we can keep moving. And then the rest of this are just pictures, especially for those of you who have never done this before and have never heard of the KidWind Challenge. It's good to kind of see what projects look like when they come. And these are from our state competition 2 years ago. So again, these are winners. They've moved on from regionals and now they're at states. So you're kind of seeing kind of the cream of the crop here. But you will notice that some of them still come with the PVC turbine, you know, with the standard vernier base. But you'll notice the one on the very far left here, that big piece of plywood under it, they glued it to that piece of plywood because the base is so light. They needed to add weight to it. And you can see that the hub that they're using is definitely not the little black KidWind hub. So they had 3D printed a new hub. And then, you know, these folks are making some amazing blades. They're adding nose cones and ribs and being very artistic. And then the great thing, the one in the center, you can see their board. This is part of their documentation. And you can see that they have a ton of charts on there showing all the data that they collected. So these are the kinds of documentations that we like to see. And they bribe people with lollipops, which is always nice, right? This is just a closer look at some of the crazy, insane 3D printed and laser cut pieces that people are generating. So, you know, the hubs with lots of screws in them, lots of gears, even different like generator holder assemblies. You can even see on the middle one where the small yellow looking gear is that there's a bearing in there to create, you know, a frictionless drivetrain. So like I said, this is the far, you know, this is how far you can come, I guess. I don't want to scare anybody away by showing them this because you don't need to show up with this your first year, trust me. Anyway, I'm going to stop there. And are there any questions about the wind competition before I get into the solar?
So with that said, we're planning on competing in the KidWind side of wind. The only real restriction there is the motor. All this other stuff doesn't so much matter.
Correct. Yeah. The only thing that determines your division is the generator. Now there's no restrictions. Like you can build it, you can buy it, you can do whatever you want. Just puts you in a different division.
Gotcha.
So like I said, it's super open. As long as it fits in the tunnel and it's safe, we're going to let you run. And it has to be rectified to DC if you do get a new generator or build a generator. So you do have to rectify it to DC, and you do have to be within the voltage and amperage limits of the energy sensor. So if you're getting crazy into that kind of stuff, just, you know, let me know and I can help you through. That's why you match your load, because you don't want to burn out our sensor, because then you're going to owe me $100. No, just kidding. Good questions. Any other questions about wind? Did I scare off all you new wind teams yet? I hope not.
Not yet.
All right. Well, that's good. All right, we're going to get into the solar. So if I scared you with wind, you can relax for a minute and we're going to talk about solar. It's going to be great. So the solar challenge is a little newer. It's still kind of getting its footing here. So we appreciate you guys being flexible as the rules do tend to change here and there. But because I'm pretty sure they're not going to actually, the rule books have already come out for this year. So if you're ready to go, just go to the KidWind website and go to, like, I'm going to do an in-person challenge and there's a rules tab and you can download the new rule books. But the rules are going to look the same as last year for the solar challenge. The way the judging works, this kind of point distribution is a little bit different just because of the new judging sheets and the way we've been doing that. But again, I think the point to take away from this is not necessarily the specific numbers, but again, that the fact that the circuit design and the functionality, like your solar house has to work, is only 35% of the score. And then what you tried to do and the way you documented it is the other, is another 50%. So it's very similar in the way that it's balanced, like the wind competition. Okay, the rules are a little different. There is this new solar testing environment that I can tell you about because we tried it for the first time last year. But for now, the solar house, again, it's a solar home challenge again this year, must fit in a 2 foot by 2 foot kind of square footage and can only be a foot high, because the solar testing environment that you see down there is only about 14 inches to those lights. And those lights are super hot. And actually last year, we like disintegrated some styrofoam roofs. And I really think we did have a fire start with something that somebody put on their roof, like maybe some moss or something. So we do need to be real careful that we leave a good amount of space between where the panels are and where those lights are, because there can be an issue there. But again, with the wind competition, you can use any materials you want. You can use any sorts of loads, snap circuits, little bits, light bulbs that you pull out of, whatever. You can use whatever you want. You can use any solar panels that you want. You don't have to buy them from Vernier. There's no, KidWind solar panel that you have to buy. But we do, for safety purposes, put some restrictions on how much power a single panel should produce, and a limitation on how much your total solar array should generate. And we can get into those details, but most of if you buy the solar panels from Vernier, they're going to be 2-volt panels. They're going to be way under the restricted levels. And then you just have to worry about how many you're stringing in parallel or series so that you don't exceed the 48 watts. We do encourage students to use microcontrollers like microbits and Arduinos. That tends to be kind of more at the middle school level, and a lot more at the high school level, when there's this actual smart home division, where they have to actually, think about some programming. And if there are microcontrollers in the circuit and in your project, then all of the code has to be printed out for when you come to competition, because we want to make sure that the students are programming this and that they can explain what they're doing, as opposed to like downloading files and things like that. It's kind of similar to like anything that we 3D print, be it wind or solar related. We need to see the shape or not the shape files, the like SolidWorks files or CAD files, and make sure that they created those files and didn't just like download them from Thingiverse or something. And then the circuit diagram, or so there's a wiring diagram for each circuit. And anyway, it gets a little complicated because you can also include storage if you want. And you can have multiple circuits within your solar home. But if you have separate circuits, you need to have a wiring diagram for each circuit. And then you also have to have a full solar panel schematic, which is different. Again, this gets really confusing. We talked about this over the summer on how we can make this a little bit easier on you all, but unfortunately, like I said, funding limitations, we didn't have the bandwidth to actually rewrite all the rules. So it's the same rules as last year. I'm going to move past this judging piece because the judging looks very different. So we have a requirement for the solar teams. It's called the Solar Team Report. And there's a lot of details if you look in the rule book. But there's team details, and this is like, just grade names of the kids, what school you're from, who's the coach, that kind of stuff. Then there's a solar home summary, and that's like the purpose of your solar home, who inhabits it, and where is this thing located. So the idea is like we're building something with a purpose, right? Somebody lives in it and it has to do certain things. We're talking about purpose and design. Oops, sorry, I didn't mean to. Whoa, wow. Sorry about all that. And then, we have to outline all the team members' teamwork and their different roles in the project team. And then there's the solar panel schematic, which this is literally like what your solar array looks like. So I have 2 solar panels in parallel, or I have 4 solar panels in series, like that's how, and it not only has to kind of show how they're wired, but it also has to show the voltage and current of each panel, and then the voltage and current of your total array. So it's really getting pretty detailed on them understanding why they arrange their panels a certain way. And then the wiring diagram is more about the loads. So understanding like what are the loads? Are they in series or parallel? Where are the switches? What are the switches doing? You know, putting them in the right places. And then if they have done something with microcontrollers, they also have to provide their code. And then there needs to be a materials list of literally every material and the price of the material that you spent to build your solar home. So it's a very detailed report, a little daunting, but these are a couple of examples of circuit diagrams. So for those of you thinking about the solar competition, it seems daunting, but you know, if you're a fourth grade team, your wiring diagram is going to look a little different than if you're like a high school student. Maybe in high school, you're using CAD to do this, or you're using FET like we did here. And then in elementary school, maybe you're just drawing it, right? With paper and pencil, simple and easy. As long as the idea is that the judges understand what you did with your circuit, because if they look at your project and your project is neat and tidy, they shouldn't see all those wires, right? And sure, they wouldn't know, is it in parallel? Is it in series? Where are the switches, right? So that's the idea. And that's the technical component really for this competition. And then a great resource if you're teaching your kids about circuitry through the solar competition. They don't have solar panels, but you have batteries and you can size them to the same size as your panels. And you can do circuit simulations through FET. Which the website is down here. It's through the University of Colorado. And then you can actually put the multimeter on here and figure out like, what's the voltage doing and what's the current doing and what happens if I add a second solar panel. And it's really a cool resource. Okay, here's a couple of projects. Again, we have lots of great documentation and bribes, apparently. Everybody likes to bribe people. And this was a solar powered water park. This was a solar neighborhood. Again, these were 2 years ago, so these aren't solar homes from last year. So it's not the theme, but just some examples. And you can see that these guys used a breadboard and they have some microcontrollers in here. So there's lots of advanced things going on here. This one, like they ran power lines. It looks nice and clean and they built it with Legos. So anyway, there's just a lot of different things that you can do with the solar. So again, I'm gonna stop here. This is the end of my solar spiel. Does anybody have any questions here?
I have one.
Yes.
For circuit diagrams, last year we struggled. We were going to use Tinkercad, but we couldn't find all the correct symbols. So we ended up found them on some strange website that allowed us to build. Are we allowed to use non-standard symbols to sort of like what you had showing on your circuit diagram slide? You know, you had a battery there, which isn't, you know, it's a visual depiction of a battery versus the actual schematic drawing of what a battery actually is with lines with dots.
Yeah, the rule book states that your wiring diagram is fine to have its own symbols as long as you have a key.
Okay.
Yeah. So yeah, get creative. Because they give you a template in the rule book, but it only has a couple of different loads on it. So if you are using things that aren't on there, you're just going to have to kind of make that up. Yeah.
Thank you.
Good question. Anybody else? Awesome. Okay, well, I think we're getting to the end. I just kind of wanted to go through some more of the details on the documentation because this tends to be the piece that, you know, we all focus on like, let's get the thing built, you know, so we're really focusing on like making our solar home work or making sure the wind turbine performs really great in the wind tunnel. But I highly recommend when you start your teams that you designate a couple of team members to be documentarians or secretaries or whatever you want to call them so that they're taking pictures the whole time and that somebody is writing down all the data that you're collecting and organizing it and making charts. Because again, we love to see the design schematic. So what is your final thing, and all of the, the measurements and identification of all the key components. This is from like this, we're just gonna skip over that because I think that was from the virtual competition. But yeah, they want to have as much information as you can provide. Like I said, a lot of people bring a 3-sided backboard. It has for some people, it's like a great place to do pictures like this one is. Some of them will have more data on the background, but some will use it for more of like a pretty, what do I know about wind or solar energy and some pictures, and then they'll have an engineering notebook that has all their data in it. So I think it comes in a lot of different ways, shapes, and forms, but that 3-sided backboard is kind of a key piece that most kids will bring. It's a nice backboard to have while they're giving their presentation. When they present to the judges, they're more than welcome to have a video or even a PowerPoint that they want to present, or a Canva or whatever. Anything they want to have in order to make sure they're getting their point across. With that, I just wanted to share with you guys some of our resources. Like I said, the next kind of round of things that we are engaging in is trainings for the coaches. So this is meant as like the prereq, because I don't want to go over this at all of the coach workshops. I want to use our coach workshops as time to dig into the materials and talk about integration and like, how do I actually start doing this with my kids? So most of our trainings are about 4 hours. The one in Shenandoah University is 3 hours in the morning on wind and 3 hours on solar in the afternoon. And you can pick which one, or you can go to all 6 hours. But all the others are like a 9 to 1, 4-hour training. Again, you're going to come, we're going to feed you. It's free. You get a free kit. So free. And we feed you, hopefully, because it's a Saturday. I know that's tough for everybody, but there's just really isn't a good day. So we'll be in Charlottesville on October 18th. We'll be in Norfolk on November 8th. We'll be at Shenandoah University Winchester on the 15th. And then on the 22nd of November, we will be in Wise, Virginia. And for those of you who are going to VAST, which is the Science Teacher Association Conference, we will have a session and I will have a booth. And so if you have any need for anything and you're going to be there, I would highly recommend reaching out to me, because I can maybe bring you a kit then. Or you can come to the session and learn more. We're going to talk about KidWind, but we're also going to talk about a lot of other things in that session, but I will have stuff to get your hands on.
I have a question and or remark on the trainings, on the coach trainings. So I attended one last year and it was a nice event, no question, but it is very much geared from my perspective to people that are very good already at working with kids and don't know what plus and minus and black and red is, and power and energy and these things. To make it drastic, I'm exaggerating here. So I was wondering whether there were any changes that kind of flip that a little bit. So if you have these like nerdy, science-y volunteers from organizations like Makersmiths that are very good about all the technical stuff already, but just don't have a lot of experience working with kids, do the trainings include elements about that?
That's a good point, Oliver. I don't know. I mean, I think, the only thing I can tell you is that we'll have multiple trainers at any singular training. So there's definitely the possibility and opportunity for like one trainer to take some of the folks who are a little bit more advanced into this side of the room and talk about something and dig into what they need to talk about, and then like the beginners into another space to talk more about a different avenue. But yeah, unfortunately, it is kind of meant for the new teacher, because that tends to be the majority of the
I totally understand. Just wanted
of the folks that we get. But yeah, but I would just encourage if you have a need that has not been addressed, to just let the trainers know, because we'll do our best to to make time for anything that needs to get covered.
Yeah,
Yeah.
and definitely, like if you're a new coach, just go no matter what your background is. Definitely helpful.
Well, I appreciate that. Yeah, and like I said, you get a free kit, and so we do have a link down here where you can go and request a starter kit. But if you're already going to go to a training, don't do that, because you're already going to get a kit at the training. So you don't have to like request a kit and sign up for the training. And then the other resource that we have available is that in each of the regions that we're hosting competitions, we have KidWind trainers. So these are folks that have been doing KidWind for many, many years. Some of them are retired, some are still coaching teams. But they get paid a very small amount of money by me to be on hand to help with teacher trainings, or pardon me, coach trainings, but also to mentor new coaches. So if you're new, and you would like to be linked with the trainer in your area, just email me, and I'll be happy to connect you with your local trainer who is an experienced teacher. I'm not a teacher. I just organize stuff, right? So I mean, I guess I'm an educator still, but these guys have a much better perspective to help you over some of the humps that you might see in the first year that you're trying this. So I would definitely recommend reaching out to them, because they are a great resource. This is what the starter kits look like. Again, the starter kits are meant more for folks who've done this before and they're starting a new set of teams. So it does not have the full PVC turbine, and it does not have a bunch of solar panels in it. It's just, some of the things that we use up every year and that you might need for a new team. If you need a full kit, like I'm starting this from scratch, I highly recommend going to a training and getting the full kit at the training. I'm gonna stop and let you ask some more questions before I wrap it up. I'm just doing such a good job. This is great. Okay, so what's next from our standpoint is we talked about the teacher trainings, but we are hoping this year to try this KidWind Expo idea again. So we had this planned last year for those of you who were involved last year. We had planned it for January at JMU, and it got canceled because of snow. But this year, it's actually February 7th. We have it planned at Virginia Tech. And this KidWin Expo is a new idea. The idea is kind of think of it like a teacher training, like a coach training, but for the kids. So we're going to bring them out on a Saturday, and they are going to get to rotate through workshops where they get to learn from experts on gearboxes and airfoils and all the things that as a first time coach, you're like, holy goodness, I'm never going to get there. But we want to give the students a little bit more ownership and accountability to learn about the things that they want to integrate into their projects. So February 7th, we're hosting one at Virginia Tech. We are planning to also offer one in the Northern Virginia area, so that you don't all have to try to get to one side of the state or the other. But we have not planned that, and we don't have a date for that yet. So just keep your eyes out. We hope that we're going to be able to do that. Very likely, we're looking to host that at George Mason in Fairfax. So we'll see. And then, yeah, the whole idea is to take a lot of the pressure off of you as coaches. So we do ask that you come with them, obviously with parents. But we have a separate track for you guys where you guys get to learn things that you might have questions about, like what does the first day of a competition look like? And, who is KidWind? And maybe we'll meet the owner of KidWind. And, maybe I don't know, we'll talk about, maybe we'll give you all massages. I don't know what we're going to do for you guys, but you guys need to take a little bit of time for yourselves and let the kids do some of the learning on their own. So hopefully that'll be a nice fit for everybody, and hopefully it'll happen, because you just never know. Anyway, it's still a work in progress. I'm happy to answer any questions you might have, but I might not have them yet. And that's pretty much it for me. So with that, going to stop my screen and like I said, we're at the top of the hour just about, so I'll leave it here if anybody has any other questions. But yeah, here to help. But if you've gotten what you need, I will let you go because it's late.
Thank you.
Yeah, of course.
Thanks so much. Have a great day.
Yeah, you
Thank
bet, guys.